don't quite need as much energy to hold them stable in the middle when they form a helium atom as two hydrogen atoms do. So these atoms, when they combine, actually release a little bit of energy. And there are so many trillions of them being converted into helium every second that all that extra energy comes out in the form of X-rays and gamma rays and light and heat. The sun even gives off radio waves and microwaves. So if you turn your radio to the right frequency, if it could pick up the frequency, you could actually hear the sun giving off static. You'd hear the noise of it. And on some radios, during the day when the sun is crossing the sky, you can actually hear the static change. It changes frequency a little bit as the sun passes the antenna. So you can actually hear the sun. If you turn your TV, I remember before cable, we used to have rabbit ears on our TVs. And we turned to channel 6. There was no channels on channel 6. And some of that snow you would see on the TV was actually signals from the sun coming through your rabbit ears on your TV. Which is pretty cool. So this telescope basically picks up one kind of energy that's being given off by the sun. We think of them as waves, these invisible waves we can't see. Now some of those waves are light waves, like I said, and the light waves that are coming at us blend together and let us see all the colors that we see. For example, tree leaves are not really green. They look green, but they're not green. What's happening is all these different rays that are coming off the sun hit the leaves, and the atoms in the leaves absorb some of those waves, and they let other waves come off. And the waves that come off hit our eye, they mix together, and our brain tells us we see green. Okay? My shirt is not really made of red atoms. These atoms are absorbing all the different wavelengths, and some of them are bouncing off. And the ones that come back to our eye tell us that it's red. Okay? So this telescope is basically taking just one of those colors, one of those kinds of waves that's coming off the sun. And it's coming from a particular layer of the sun that's very active. There's a lot of storms and a lot of eruptions going on. So we see a lot of detail in that one layer, and that's why this telescope lets you see lots and lots of detail. But what I can't see really well with this telescope, that those telescopes let you see, are some of the sunspots, the storms, the big storms, magnetic storms, because those scopes are letting in more rays of different kinds, and those rays are taking different layers. And the storms exist in a lot of different layers, so you can see the whole storm in those scopes. Whereas mine can only see one cross section.
He's down there somewhere.
The difference is different layers of the sun all at once. It looks a little fuzzy because one layer is sharp, but then the next layer on top blurs it. So there you can see the little tiny eruptions as well, but you see the storms, the overall storm much better. This looks at one layer, so you see the details much sharper. Okay. All right, so that's why the sun looks like a red ball, because we're getting that one color of red. Like if you think about a rainbow, you get sunlight passing through raindrops, and the raindrops act like special lenses that spread out the light into all those colors that the sun is giving off, right? The rainbow of colors. And there are a lot of colors that are blended in there. There are millions of colors that you can't even see with your eyes. They just kind of blend in. So the sun gives off thousands and thousands of different colored waves, and this telescope sees one of those types of waves. This thing is a 60mm aperture. It doesn't need to be very big because the sun is so bright. That's the thing about telescopes. A lot of people confuse telescopes' power with how good they are. The power really comes from the lens that you put in at the bottom of the telescope. I can change this lens and change the power of this telescope. I can make this telescope as powerful as the biggest telescope here with a different lens. But what's important about a telescope is not the lens, the magnification, the power. What's important is how big the aperture is, because think about it. Your eye only lets in this much light when you look up at the stars in the sky at night, right? And that's not very much light. If you could have an eyeball this big, it would let in all that light and concentrate it on the back of your eye and make it look brighter. So if you can take a telescope and make a bigger aperture, make a bigger lens, or in some of these telescopes have a bigger mirror at the bottom that's shaped like a satellite dish, that light comes in and gets concentrated to a point. That intensifies the light. It's like a magnifying glass. It doesn't just make it look bigger, it makes it look brighter. So the bigger your aperture, the brighter it makes objects look, so you can see things farther out.
This one's dead. Yeah, you can have a peek. No. Just it doesn't have enough brightness.
That's why big telescopes.
This filter is blocking too much sunlight.
Well, it's also true of telescopes too.
I might as well take it apart.
I see the sun coming back. Let's see if we can get it back here. Maybe we can get some people looking at the sun. Hopefully. Red shift stars.